Okay, so on example 6, John is choosing between 2 majors in college, either architecture or engineering. Okay. All right, so what you need to do is, because I couldn't do this in your notes, because whatever, I just didn't, you're going to draw those lines. So he's choosing from architecture or engineering. If he chooses architecture, okay, from there he either has to go into residential or commercial architecture, okay? If he does engineering, once he chooses engineering, he needs to choose between mechanical and electrical, okay? So would we say these are independent or dependent events? Dependent. So depending on if he chooses architecture, then he has to make another choice. And if he chooses engineering, then he has to choose another choice, okay? And some of you guys are going to be dealing with this pretty soon with making college choices. Okay. Now, remember that when you're finding probability, you're always multiplying, okay? With these, we're multiplying, okay? So, what it is telling you, it says, if the probability of architecture and commercial equals 72%. So what that means is if you multiply architecture and commercial together, it equals 72. Do we know does it say what the probability of architecture is? No. So right now what I'm going to do is I'm going to give this architecture an X. Okay? And commercial we know is, no, it's 90, right? Do you guys see that? Okay, so what they're saying is that when you multiply these two together, it equals 72%. Okay? I'm going to write these as decimals though because I'm going to convert my percent into a decimal. So what this means is 0.90 times x, or 0.90x, equals 0.72. Because they said that when you have architecture and commercial together, it equals 72%, which is 0.72. So how would I solve to find out what architecture is? Very good. That's exactly it. You would divide 0.90 to both sides in order to get x by itself. So if you take out your calculator here, and if I go 0.72 divided by 0.9, we get 0.8. So that means x equals 0.8, which is what is a percent? 80%. So that means right here, my architecture actually equals 80%. So on A, it says find the probability of architecture. So there's an 80% chance that he's going to choose architecture. Okay? Now, we learned through this whole unit that both of them have to equal 1, right? He has two choices. He has to choose architecture or engineering. So if architecture is 80%, how much is engineering? 20%. Okay? Is this good? All right. If you pay attention, this stuff isn't too bad. All right, so we're going to move on to our next example. That's it. Yeah, because this was A. So A is 80% and B is 20%. They asked for those two things. Okay? All right, example 7. Okay, the employees at PAL Distributing are listed below. So at this place of work, there's men and women, and there's college grads and non-college grads. Okay? So do you guys see how all those columns work? Okay, also at each of the bottoms they have the totals. So if you add all of the college grads and non-college grads together, there's 24 of them, and if you add all the men and women together, there's also 24, right? Those numbers should be the same. Okay. So this question says, what is the probability that if you randomly pick an employee, it'll be a female given that you pick a college grad? Okay. How this works is, this is your formula, okay? I think that the easiest way to do it, though, is this way. So it's asking you, what is the probability if you pick an employee, it'll be a female given that you pick a college grad. So your first one is your and. So you're going to, where are females and college grads? There are 12. Very good. So your top number is your and. It's where they are together. Okay, so this top number right here, this is 12. And then you always divide it by whatever comes second. So in this thing, when it says given that, whatever comes after the given that, that's your second term. In this case, it's saying college grad. You want the total for college grad. So what is your total for college grads? 19. And then you reduce it, and that's your answer. Can that reduce? Nope. That's your answer. Okay, so I'm going to give you another one to try. Okay? So we're just going to have a second one. So my question is, what is the probability that if you randomly pick an employee, it will be male given that you pick a non-college grad? So I'm just going to give you guys 1 minute here. I'm going to give everyone a second to try. So I'm just waiting for everyone to have a chance to try it on their own before we yell at answers. Oh wait, that already happened. Okay. So our top number is always the two together, right? So our top number is male and non-college grad. So how many are male and a non-college grad? 2. Do we all agree with that? Yes. So our top number is 2, and then we always divide by the total of what came second. So what is the total of the non-college grads? 5. And that could be reduced if possible, but it can't be, so my answer is 2/5. Okay? Yes? Okay. We're not going to do 8. It's not going to be on your test, and so we're just not even going to worry about it. Sound good?
Is it 100 though? 100%?
It's actually 0.24 is your final answer. Did anybody get 0.24 for their answer on that one? Good job, Chris. All right. You did? Oh, okay.